Alright, this is practice problem 6.1, and there's three parts to this. First is, what is the frequency of radiation that has a wavelength of 10 micromole? Okay, so if we know that we have a wavelength which is equal to 10 microns, okay, 10 micrometers, and we know that c is equal to lambda times velocity, okay, then we know that velocity is equal to c divided by lambda, okay, the wavelength. And so we know that the speed of light is 2.998 times 10 to the 8 meter per second. Okay, and we know that the wavelength is 1 times 10 to the minus 5th meters. Okay, so we converted the 10 microns using 10 to the minus 6 meters in 1 micron meter. Okay. And so we get 1 times 10 to the minus 5th meters. Okay, and then solving for this gives us 2.998 times 10 to the minus 13 inverse seconds. Okay, which is then going to be equal to 3.0 times 10 to the minus 13th inverse seconds. Okay, part 2 asks, what is the wavelength of radiation that has a frequency of 2.5 times 10 to 8 inverse seconds? Okay, once again we know that c is equal to lambda times the velocity. Okay, the velocity we're given, or I'm sorry, the frequency is 2.5 times 10 to the 8 inverse seconds. Okay, and we know that the value for the speed of light is 2.998 times 10 to the 8 meters per second. We have that equal to lambda, which we're solving for, times the frequency, 2.5 times 10 to the 8 inverse seconds. Okay, and so we solve for lambda, and so the wavelength is equal to 1.992 meters, which is basically, 1.1992 meters, which is equal to 1.2 meters. Part 3 says, would the radiation either part A or part B detected by an X-ray detector? Okay, so A would be in the infrared region, while B would be in the radio frequency region. So that answers both parts.